Okay, welcome to section 2.1, which is percentages and proportions. So percentages and proportions. Okay, so what is a percent? Definition. Oops, let me underline that a bit better. So definition, a percent, which we will analyze the name of, is the number in the numerator, meaning on top, in the numerator of a fraction with denominator equal to 100. Equal to 100. So that is n% means n divided by 100. Okay, so let's note something about percent. Note, if we parse the word percent, per cent, we can think of the per as over or for every, and we can think of the cent, what color should I use for this? Like 100 pennies or 100 cents. This is 100, so cent means 100. So when we say percent, we're really saying we're saying over whatever percent it is over 100. So for example, so let's express the following as percentages. So express the following as percentages. Okay, so number one, let's say we have 3 over 100. Pardon me. So 3 over 100, this is 3 over, and we already have the 100 on the bottom. So by definition, this is 3%, meaning 3 over 100. Okay, so let's say I had, let's do 5 over 10. So at this point I have 5 over 10. 10 is not 100. So in order to get 10 to be 100, I would need to multiply top and bottom by 10. Whatever I multiply on the top, I multiply on the bottom. So what this will give me on top is 30. And now on the bottom, or the denominator, 10 times 10 is 100. So therefore I can now write this as 30 over 100 or per cent. So 30%, meaning over 100. Okay, another, number 3. Let's say I have 0.45. So decimals, 0.45. In order to move a decimal to the right, we need to divide by however many zeros. So it's going to be a 1, followed by however many places I move to the right in terms of zeros. So this is 1. Actually, let me put a 0 and a 0, because I moved 2 places to the right. So therefore I divide by a 1 with 2 zeros attached. So this is now 45 over 100, otherwise known as per cent. Okay, let's do another one. So number 4, let's say I give you 13 over 25. So now this is really bad, right? What would I need to multiply 25 by? Let me write it in orange in order to get 100. Basically, how many quarters make $1? That's 4 quarters make 100 pennies or 100 cents, right? So I would need to have 4 quarters. So in the numerator, 13 times 4, that might seem difficult, but let's first calculate what's 10 times 4. So 10 times 4 is 40, and 3 times 4 is 12. So 40 plus 12 is 52. So that's how I would multiply in the numerator. And 4 quarters makes $1, so I have 100, meaning this translates as 52 per or over cent 100. Okay. Okay, so let's note. So to find the percentage of a given value, we multiply whatever value we're given by the percentage sought. So to find a percentage of a given value, we multiply that value, usually a dollar amount, so that value, by the percentage sought. Like say you have to pay 10% tax. Okay, so for example, so find the following percentages, and you'll hear my kitties singing in the background. Okay, so find the following percentages. Okay, so number 1, let's say that a tax rate of 10%, or a tax of 10% on a purchase of, let's do $63. Okay, so I have my tax rate 10%, right? So I want 10% of what? Of the amount given, which is $63. So I need to multiply. Of in math means multiply. So actually I can put the zeros down here, not that it matters. Okay, so 10%. The easiest way to do this is to translate this as 10 over 100. And since I don't really need the decimal here, I'll just multiply this by 63. And what's nice, whenever we have zeros, we can reduce. So let's reduce at least 1 0. So what this gives us now in the numerator is 1 times 63. And in the denominator, I'm dividing that by 10. So if I am dividing by something with 1 0, I move the decimal to the left 1. So the decimal will now be 6.3 instead of 63. So in terms of money, I tack on a 0 and I get $6.30 as my tax rate. So hopefully that makes sense. Let's do another one. So subscript number 2. So let's say an $800 iPad. An $800 iPad is on sale for 25% off. Is on sale for 25% off. So if the tax is 10%, find the final cost. So find the final cost. So we have to analyze this a bit first. First, we need to know what the discount is. Well, the discount is 25% off, agreed? So let's do that, pardon me, in yellow. So 25% is my discount. So it's 25% of the original amount, which is 800. So of means multiply. So I'm taking 25% of $800. And I know that 25% is really 25 over 100. And I'm multiplying that by 800. So all of the zeros are going to reduce. These two zeros with these two zeros. And I'm left with 25 times 8. So if you have 8 quarters, how much money do you have? Well, it turns out that you have $2. So this is $200. $200. That's my discount. Okay. So maybe I should have done the word discount in purple since that's what I used. Not that it matters. Okay, so my discount is $200. So my cost, sale price, let's say sale price. Sale price is going to be, well, the original amount minus the discount, right? So it's going to be $800 minus the discount of $200. So my sale price is $600 prior to tax. So now my tax will be, well, the tax rate is 10%. So it's 10% of the $600. Okay, so 10% means 10 divided by 100 of 600. So once again, the two zeros here are going to reduce. And I'm just left with the numerator, which is 10 times 6 in terms of money. So my tax rate should be $60. So now my final cost is going to be sale price plus tax, right? So it's going to be $600 plus the tax, $60. So my final cost will be $660. Okay, so there we are. $660 for your iPad if it's 25% off at a tax rate of 10%. So now let's consider absolute versus relative change. Absolute and relative change. Relative change. Okay, so absolute change, and usually we're talking about a change in price, a change in number, change in something. So the absolute change in something is given a start value. So given a start value, or starting value rather, starting value of, let's call it S, and an ending value, and a final value, let's call it a final value, F, little f. So the absolute change, absolute change in price or in number or in value is given by the absolute value, meaning it always has to be positive, of final amount minus starting amount. So absolute value means positive always has to be a positive. So let's say you went down, you lost $5. The absolute change would be $5 even though you lost 5. Okay, so the next definition would be a relative change. So with respect to, say, the initial value, how much did you lose? So a relative change, you have to relate it to something. So the relative change is given a start value of S. So given a starting value of S and a final value of F, little f. So the relative change, and in parentheses, this is with respect to, so with respect to the starting value S, so respect to the start value S, or starting value S, is given by okay, so it's going to be the absolute value of final amount minus starting amount. So that looks like the absolute change, but now I'm going to divide it by the starting amount. So notice this is with respect to the starting value, S. So notice that the starting value is on the bottom here. Okay. And let's note something about relative change. So note, because we're dividing by that S, relative change is actually a percentage. So relative, why am I having so many issues? Relative change is a percentage. So maybe you lost 10% of your product, or maybe you gained 5%. It's always going to be, how do we change? Relative change is a percentage. So for example, okay, so suppose the support of measure A on a ballot. So suppose the support for measure A, measure A increased from 60%, so increased from 60% of voters to 75% of voters. So find the absolute and relative change in percentage. So find the absolute and relative changes in support for measure A. Support for measure A. Okay, so let's have our start value. So starting value, S in this case is 60%. So what color shall I use? Let's use purple. So final value, F for us is 75%. Okay, so the absolute change is just going to be the absolute value of starting, or final minus starting rather. So it's going to be 75% minus 60% in absolute value. So how much percent did we lose here? It looks like, well, why is that not? So 75 minus 60 is 15%. So it's a change, an increase of 15%, which makes sense. But what is a relative change with respect to the initial amount? So the relative change, basically 15% is how much of 60, the starting value. So the relative change will be the absolute change on top, which is 75%, minus 60%, so it's the same thing on top. But then we divide it by the starting percentage. And in this case, the starting percentage is 60%. So I'm going to divide this by 60%. So what I end up with then is the 15% in the numerator from the previous problem, which I'm now dividing by 60%. So ironically, my percentage symbols reduce, and 15 goes into 60 how many times? It actually goes in 4 times, so I get 1 over 4, which is 25%. A quarter is 25%. So let's note that. So note, it's an increase in voter support by 25%. If I go from 60% of voters to 75%. So 1 over 4, in order to get 4 to be 100, I would need to multiply top and bottom by 25, because 4 quarters makes 100. So when I do that, I would have 25 divided by 100 on the bottom. Hence, I would have 25 over 100, otherwise known as percent. Okay, so next page. So let's note, or let's have a definition. So definition. This has to do with what is the absolute value. So the absolute value just in case you're not understanding it well, so the absolute value of any number n, let's call it little n, denoted by, why is this not writing? Denoted by what? Straight up and down lines of n is its distance, from 0 on a number line. So from 0 on a number line. So note, because it's a distance, it's always positive. So note, the absolute value of n is always positive, because you can't have a negative distance. Always positive, because it's a distance. So because it measures distance. There's distance. Even if you're going in reverse, it's still a positive distance. Okay, so what do I mean? So for example, let's evaluate the following. So number 1, say I have the absolute value of -5. So what this is, the absolute value of -5 is equal to the distance from -5 to 0 on a number line. number line. So let's go ahead and plot that number line. So I guess I'll put it up here. So let's say we have 0 here, -1, -2. Oops, that's a terrible -2. You actually put these on the line. So -2, -3, -4, and -5. So here I am at -5. So how far away? What is the distance between -5 and 0? Well, that distance is 5 units. So the absolute value of -5 is going to be 5. It's 5 units, or counting numbers away from 0. Let's do at least one more for good measure. Hopefully this will make sense. Let's do the absolute value of +4. Okay, so this is the distance. So the absolute value of +4 is equal to the distance from 4 to 0 on a number line. Okay, so let's go ahead and draw this number line. So let's have 0 be here. 1, 2, 3, 4. 1, 2, 3, 4. So my number is here at 4. And I want to know what's the distance to 0. How many units here? Well, that distance is 4. I'm 4 counting numbers away. So the absolute value of 4, which really means the distance to 4, from 4 to 0, is 4. Okay, so hopefully that makes sense. Understanding absolute value is just a distance. Okay, so now let's do proportions and ratios. So proportions, and ratios. Okay, so definition. So a rate, that's what we're defining. A rate is the ratio, meaning fraction, is the ratio, that is, i.e. fraction, of two quantities, A and B. That is, so ratio is equal to A divided by B. And note, if B is 1, so if B is equal to 1, so then A is termed the unit ratio. Then A is called a unit ratio. Okay. So what do I mean by this? Usually a ratio means a rate means like miles per hour, gallons per minute, something like this. It has to do with some per. We usually use the word per, kind of like percent. So if I can drive 300 miles on 15 gallons of gas, what is my mile per gallon rate? So what is my MPG? Miles per gallon. Miles per, meaning over, gallon, rate. So remember, per means over. So what do I want to find? So want to find miles, and per means over, right? Per. Let's do, actually let me change these colors. Let's do miles, and let's have gallons be yellow, shall we? Miles per gallon. Okay, so these are the units I want to find. I'll call this blue because that's going to upset me. Okay, so do you agree that I can simply write miles per gallon as what was given? How many miles do I have? 300 miles. So I start with what's given, 300 miles per, meaning over, per. And how many gallons was I given? 15 gallons. So 15 gallons. Okay, so 300 over 15. Well, I know that 15 goes into 30 twice. So this must be 20. And then miles per gallon. So there we are, miles per gallon. 20 miles per gallon. Okay. So let's say I can do another definition here. Definition. So that was a rate. What's a proportion? So a proportion equates two ratios. So a proportion. That's what we're defining. So a proportion equates two rates or ratios. Two rates or ratios of, or ratios. Okay, so for example, so if you can drive 200 miles in 4 hours, so if you can drive 200 miles in 4 hours, how long will it take you to drive 25 miles? So how long will it take you to drive 25 miles? Okay, so first I want to find what is my rate. So first find the rate or ratio. And what rate do we want to find? We want to find miles per hour. So miles per hour. So this is now time, miles per hour, MPG, miles per hour, right? Then we'll deal with the 25 miles. So my rate will be 200 miles per or over 4 hours. 4 hours. So what is that equal to? Well, 4 goes into 25 times, so I'll just tack on a 0. So I claim that that is 50 miles M per P hour H. So 50 miles per hour. Okay, so now I want to find how long. So how long will it take? So now I want to find time. So second, find time. So just time. So for us, that's going to be hours, right? So how am I going to use my rate to get to hours? Well, I can set up a proportion. So what do I know? I know that I drive 25 miles. So I drive 25 miles. So 25 miles. Miles is what I'm going to start with. And in order to cancel miles, because all whole numbers are over 1, I'm going to use the ratio 200 miles per 4 hours, which is really 50 miles per hour. But I'm going to write it a bit differently. I'm going to write this as 50. Oh, no, I can't. I need to. Here, let me go back here and write this out formally. This is 50. I have miles on top. Miles per. And on the bottom, I just have 1 hour. So I can just write the word hour. So this is a unit measure because I have 1 on the bottom. So 50 miles per hour. Now, if I wanted to cancel miles, let's call this blue, I would need to multiply by something that had miles on the bottom. So what I'm going to do is I'm going to take this fraction, 50 miles per hour, and I'm going to flip it upside down. I'm going to multiply by 50 miles on the bottom, and I'll put my unit measure of 1 hour on top, because now I can reduce the unit of miles, and I'm left with 25 divided by 50 hours. All I have left is a unit of hours on top. And I can make it plural if I want to. Okay, so how many times does 25 go into 50? Well, it goes in twice. So this is 1 over 2, or half an hour. So it takes half an hour going 50 miles per hour to drive 25 miles. And hopefully that makes sense. I know this was a bit difficult, but rework it and see if you can understand it. And I will see you guys in the next section.